Okay, part 2 of this video. By the end of today, you just need to have all of this finished. So all of pages 2 through 6. So you notice it says right here that we're going to do this on Tuesday, talking about what a one-to-one function is. And we talked up here previously about when a function and the x's do not repeat, that's when it's a function here. I don't have my x's repeat. Over here, my x's repeat, they show up multiple times. So that makes it not a function. So now down here, when we're dealing with one-to-one functions, it says that no two elements in the domain map to the same element of the range. So now, this is worrying about the y repeating. If your y repeats, like over here, you'll notice that -2 and 1 both go to 3. So now I have an ordered pair of -2, 3, and I would have an ordered pair of 1, 3. So my y repeats, not 1, 2, 1. This one here, my y's don't repeat, straight line. Y's will never repeat on straight lines. So down here, now we have to do this part. So if you go back to yesterday's notes, one-to-one or not one-to-one, we're looking for our y repeating. So here, we're going to see that my y value of 1 repeats. So not only is this not a function, so this goes back to yesterday, so not a function, it's also not 1-to-1. Same thing here, all of these points repeat. My y repeats. So yes, this is a function, but no, it's not 1-to-1. And then here, my y repeats again. So my x repeats and my y repeats. So it is not 1-to-1. And finally, we have one here. My y, even though it looks like this is one of these tricky ones, this is a special type of function. Let me zoom in here. These points are never actually the same. The difference, though, between here and here, so like this point here and this point here, is like 0.0001. So technically, this function is 1-to-1. Our standard one, though, if we go back up here, these are the easy ones to identify that are 1-to-1. Your straight line functions, this is more of a special case. So down here it says a function can model a real world situation, and then it says determine a reasonable domain and range of each function. So we're talking about filling a swimming pool at 10 gallons per minute, and the domain represents the amount of time that it takes to fill it. So what is a reasonable domain? Well, in order to figure out what our domain would be, we would actually have to do 10 into 10,000. And if we did that, okay, we know that 10 goes into 10,000. I just grabbed my calculator and said it goes in there 1,000 times because we just add 1 0, I guess, from the 10. So 10 gallons per minute. So what is a reasonable domain? Well, we can't have a negative domain. So if we graph this, it would be between 0 and 1,000 minutes. Because if we went over 1,000, the pool would overfill. And then the range of the possible gallons that you could have in a pool would be 0 to 10,000 gallons in a pool. All right. And so a restaurant needs to order chairs for its table. And it says one table can accommodate 4 chairs. So you think about a restaurant, how many tables? So if we go back up here, it says describe a reasonable domain. What's a reasonable number of tables you might see in a restaurant? I take a guess. A reasonable domain, if you went into a small place, probably you could have maybe 5 tables, all the way up to, I don't know, 50. I don't think you go in very many restaurants where you have more than 50 tables. And I would even accept answers, because if we're talking about reasonable, 75 is probably reasonable. But if you told me that you went into a restaurant with 250 tables, I'm not sure if that's very reasonable. And same thing here. So if I was doing that, and now one table can accommodate 4 chairs, so a reasonable number of chairs, well, we multiply both of those times 420 to 200. Does that seem reasonable? I think about some of the restaurants in town. You know, our smallest one, like the place downtown in Davison, their little sub shop down there, they only got a couple tables in there. So they might only have 4 or 5 tables. But then we think about the bigger restaurants, like maybe Black Rock or Lucky's, you know, they might hold up to 200 people. So that's what, when we talk about reasonable, there's not necessarily a right or wrong answer, again, unless you put something down that's just obscene. And up here, and actually on both of these, you can't have negatives. Bowler pays $2.75 per game. So this would be, you have to pick what your thing is. So X, we could put X as be the number of games. And then Y is the total cost. So we could do that. So X represents the number of games. Y represents the total cost. What's a reasonable domain? I don't know. You could do anywhere from 1 to 6 games, we'll say. That's a reasonable domain. And if that's the case, you spend anywhere from $2.75, and then if you did 6 times $2.75, the range 6 times $2.75 is, I think, $16.50 off the top of my head. Okay, and last one here. Oh no, I'm sorry, we got a couple more after that. It says a car travels 25 miles using a gallon of gas. So domain is gallons of gas. And again, if we wanted to, it doesn't necessarily ask these on 11 and 12, but if we wanted to, you know, maybe, I think most cars are going to have at least 10 gallons in it, and maybe up to 25 you get to your bigger trucks. And so that means if you're going 25 miles to the gallon, range represents how many miles you go in this case. So we could go anywhere from 250, because that's 10 times 25. And then 25 squared is, I believe, 625. Let me check that real quick so I don't misspeak. Let's see, 25 times 25. Yes, it's 625. And for those of you that drive, which you guys are freshmen, so you probably don't yet, that seems pretty reasonable. So continuous domains and discrete domains. So this is the last thing, I believe. Yes. Continuous is when we do straight lines. So we could go back to some of our examples and figure out some of them are better suited by a continuous line and some of them are discrete. And I always remember the following to help me remember. Discrete dots, they both start with a D. So if we think about the tables and chairs example, dots would be best representing the situation because you don't order half of a table. However, over here, you could always figure out how many gallons is in the pool based on how many minutes it is. And at 30 seconds, you could figure out how many gallons are in there. And at 7 minutes and 10 seconds, you could figure it out in all the way through your reasonable domain and range. So there are a couple others. Bowlers, most places charge by the full game. So you could argue that's discrete, although I have been at some bowling alleys where they break it down. So that one you could probably do either. This one here, when you're traveling, you can use part of a gallon of gas, so that's continuous. And then up here, we already did those two. So I think we could argue that one being either. So now we come down here. Look at these. Look at the problems for 11 and 12. We just did that. Those answers are up here. I think probably with bowling, the correct answer based on this, most places you're probably discrete. You round up to the nearest game bowled, although, like I said, I've been to bowling alleys that do both. Car is definitely continuous though, because you can use part of a gallon of gas. So now we're going to come down here and we are going to do 1 through 12, which you should have already done. And now we're going to go all the way to 24. So you're going to do 1 to 24 all. You should have already done 1 through 12. The only thing you have to come down here is you have to add this part here, whether it's 1 to 1 or not. And remember, we're looking for that y value repeating. So I'll do the first couple. Those y's repeat. Okay, so your y repeats there. So this is not 1 to 1. So this one is 1 to 1. That's another one of those kind of weird examples where it changes ever so slightly. This one here is not 1 to 1. Because again, this repeats here and here, or here and here. You can continue on. We notice down here, it says identify a reasonable domain and range. So that's what you're doing. You got to pick. You need to tell me X and Y, and then a reasonable domain. So an airplane is the time of the flight and the distance traveled are the two things here. So we could do X is the amount of time, and Y is distance. And I did Y distance because your distance is dependent on the amount of time you've been in the air. What's a reasonable time for a flight? If we go, Flint to Detroit, it's like a 30-minute flight. So we could do 30 minutes, and then if you fly all the way over around the other side of the world, I don't know, we could say reasonable all the way up to 24 hours. So if we talk about distance, that one doesn't really work because you take off slower and faster, but what's a reasonable distance? Really the distance, I guess, can be anything you want. So it wouldn't 100% match up here. I guess your time could be, you could take a 1-minute flight. I don't know why you'd want to do that, but what's a reasonable distance you take an airplane? I don't know, reasonable, maybe 30 miles. All the way up to, if we did 24 times 500, now we're looking at approximately, if I just did rounding, 500 times 10 is 5,000. So if we did 24 hours, I don't know, we're somewhere around 12,000 miles. That's just complete ballpark rounding. So that's what you're doing on all of these all the way down. And then down here, solve each problem. You need to show your work every step. That's going to be big when you get to your final exam here that you're taking here in a couple of weeks. So we're going to start circling in some review problems. And same thing here. Slope-intercept form is y equals mx plus b. So you can't just write on this one like y equals 12x minus 24 and think that that's the right answer. There should be 3 to 4 steps. And you might have to write kind of small, but you get the picture. So that's wrong. So that's it for today. Finish this worksheet up and get it uploaded all the way 1 through 24. So everything should be done. So I want you just to upload absolutely everything and we'll get it all graded on one day. Have a good one.